So let's see, where were we? I was talking about just going through this. I saw when I corrected the quizzes that a couple folks had problems with factoring, so I wanted to make sure I went through this. So the X method, no, I draw a big X and I've got A times C over B. Well, that's when I break my quadratic equation down like this. A, B, and C are the coefficients or the constants in each of the terms, right? So in this problem, what's my A? Yep, it's 12, and then what's my C? 5. So 12 times 5 is 60. And so then I need two numbers that multiply to give me 60, but when I add or subtract them, I get 23. So I got 20 and 3. So now I rewrite my quadratic equation, only I substitute b with these two numbers. So I'm going to say 20d plus 3d plus 5. So I substituted, yes, because I'm about to show you. So the thing is, the thing is, what number and what variable can be factored out when I think about this right here, 4 and what? 4D. So I can pull out a 4 and a D, and then what's left? 3D plus 5. Now, when there's nothing in common, you still have to pull a number out. So you always pull out a, if there's nothing in common, you just pull out a 1, and then I got 3D plus 5. So now, these two things should be exactly the same. If they're not exactly the same, then you need to go back to the drawing board because you made a mistake. But if they're the same, the first thing I write down, put my parentheses around them, and then I write the last two numbers that are there. So I got 4D plus 1. So that's my answer for factoring this is 3D plus 5 times 4D plus 1. Now you could have changed it like the lady was saying. We could have said 12D squared plus 3D plus 20D plus 5. And then I could have looked at the first two. Come on. So if I look at these first two here, what do they have in common? 3D. So I'm going to pull out a 3 and a D. What's left? 4D plus 1. And then I look here. What do these two things have in common? A 5. So I'll pull out a 5, and then what's left? 4D plus 1. See? How it doesn't matter which way you go, you still get the same stuff. See? Doesn't matter. And then I got 4D plus 1, and that's in parentheses, and then I say 3D plus 5. So either way will work just fine. It doesn't matter which order you put these in, just as long as you make sure your signs are correct. Because sometimes one of these numbers is negative and one of them is positive, and you want to make sure that that's right. All right, so that's how we would do any of these four. Any of those four, X method. All right, so now I'm going to number 2. Simplify each rational expression to the lowest terms. Be sure to specify the excluded values. Now, there were some conflicting things when we're looking at problems depending on the instructions. They said simplify them. So I want to simplify these rational expressions, but I also want to talk about excluded values. So, like for instance, if I look at this one right here, a lot of, well, not a lot, but some people had a problem factoring this. If I look at this top number, what do you guys see? Or top equation, excuse me. Talking about B. What do you see? Say it again. Yep, that's the difference of squares. Now the thing is, because 4x squared is a perfect square, that ends up being 2x. And because 64 is a perfect square. That's 8. That totally qualifies. Or you could say, I'm going to pull out a 4 and I'm left with x squared minus 16. And what is x squared minus 16? Well, where I was going was that's the difference of squares too. So, yep, you could do the same thing. So you could either take the difference of squares like this, or you could factor out the 4 and take the difference of squares like that. Either one would be acceptable. All right, so if I did the first one, I'd have 2. Well, you know what? Let me show you what the problem is with that though. I just thought about it. If I do 2x plus 8 and 2x, oops, that is not an x, 2x minus 8, and then I'll put this over here. Let's see. I need two numbers that multiply. Oh wait, look at this. What's the first thing I need to do to that? I need to bring out an x first. So then that's going to be x squared minus 8x plus 16. All right, so let's move this so we got some room to write. So up here though, what ends up happening is I can factor out a 2. I can factor out a 2 from both of them. So I'm going to have 2x plus 4. Yes. And then I'm going to have another 2 times x minus 4. Well, then that's 4x plus 4 times x minus 4. So that ends up being the top anyway. And then for the bottom, I'm going to have an x pulled out. And then I'm going to have x, what is that? Minus 4 times x plus 4. Oops, I'm sorry. No, that's right. Yeah, that's right. No, that's not it. I'm sorry. I'm special. This is not the difference of squares, so that shouldn't have been like that. That should be x minus 4 and x minus 4. Sorry about that. Now, if you want, you could do the x method here to see what that is. Or you could just do the brute force method. I say, okay, x squared, that's x and x. I need a positive 16 when I multiply, but when I add, I get a negative 8. So that means both my numbers are negative, because the positive here on the last term tells me that my signs are the same, and then the negative here tells me that both my signs are negative. 4 times 4 is 16. 4 plus 4 is 8. So that's what I got. Now here's the rub. The rub is be sure to specify the excluded values. Before I start canceling stuff out, I should think about the excluded values first. Because if I start canceling stuff off here and I forget that it was there, I might miss something. It just so happens that x minus 4 and x minus 4, they're the same. So I definitely have positive 4 as one of my excluded values. So x cannot equal positive 4. But what else is there? What else is there? There's another value there that has to be excluded. X, but what is it? Not 1, not negative x. It's the same thing that we were talking about with that. It's 0. I think I'm about to explain. Oh, okay, I'm about to explain. So I've got three things that are being multiplied. X times x minus 4 times x minus 4. Does everybody see that? The zero product property says if you multiply 0 times anything, it's 0. Don't matter what it is. So all I need is one of these things to be 0. Well, if I plug in 4 for x, I'm going to get 4 times 0 times 0. So 4 can't work. If I pick 0 for x, these over here, they would just be negative 4. That's fine. But if I pick 0 for x out here, it's only x. If I plug in 0 there, that's 0 times this, so it's 0. So my excluded values are 0 and 4. And now I do my simplification. So I can cross off that. These don't cross off. So my final answer is x cannot be 0 or 4. And then my simplified version is 4 times x plus 4 over x times x minus 4. I can't do any simplifying there, and that's it. Because that x right there screwed a lot of people up when they were doing the quiz. Remember what the zero product property says. It says the products right, can be 0 if one of those pieces is 0. I'm multiplying x times x minus 4 times x minus 4, right? So what all I need to do is I set each individual piece equal to 0. So I got 0 x, so that's x equals 0. I got x minus 4, that's x minus 4 equals 0. I got x minus 4 equal to 0. I set those to 0 and solve. This one doesn't need to be solved. It just says x equals 0. So that's where I get that from. Does anybody have any questions on that? All right. Please watch that because that was tricky for a lot of folks. Let's see what we got. Okay, so like this one for instance. What can I do on the top? I can pull out a 3. So if I pull out a 3, I've got x squared minus 25. And then I want to factor the bottom. What does that factor to? Now you could either do the X method or the brute force. So that is not plus 5 and minus 5. That's the same mistake that I made when I was up here. So what is that? My my sign right here is plus. So that means both my signs are the same. This is plus. So both my signs are plus. To get x squared, I need x and x. And then to get 25, I need 5 times 5. I didn't hear you. I said no about the x plus 5 and x minus 5. I said no about the x plus 5 and the x minus 5. All right? All right? Okay. So then I look at the top. The, so my exclusions right now are going to be x equals negative 5. And then I do some factoring on the top, and I get x minus 5 times x plus 5. And then on the bottom, I get x plus 5 times x plus 5. So I got my excluded value. X cannot equal negative 5. And then I cancel that off, and my answer is 3 times x minus 5 over x plus 5. With x cannot, with the excluded value, x can't equal negative 5. All right, so are we straight on that? Well, I am recording it, so you can always go back and look. All right, so any questions on the first one? I don't think I asked that. X method. It's not really that complicated. Just do the X method. All right. Now enter the determine the domain for each rational expression. So what I'm doing is I'm setting each of the denominators to 0 and then solving. So m squared minus 81 equals 0. So I could factor that and get m plus 9 times m minus 9 equals 0, or I could add 81 to both sides. Oops. So x squared minus 81 equals 0, and I add 81 to both sides. So then that I would get m squared equals 81. And so then when I square root both of them, I get plus and minus 9. So either I could get plus or minus 9 that way or plus or minus 9 that way. Because the thing is squared, it doesn't matter if your m is positive or negative because it's squared, the negative is going to cancel off. So my domain for A is all real numbers except negative 9 and 9. All right, does anybody have any questions on that? All right, then I do the same here. Well, I got k squared minus 3k. No. Well, how about we go k, as in we pull out a k, and then we got k minus 3 left over. And so we see what will make this 0. Well, I see I got k minus 3, so that means k cannot be positive 3. Is there anything else? Or 0, because there's a k that's on the outside. It can't be positive 3 or 0. So my domain is all real numbers except for 0 and 3, or 0 and positive 3. Does anybody have any questions on that? All right, so like for this problem, I could pull out an x and I get x plus 9, and then I say equals 0. And then I solve for each of those. X equals 0, x plus 9 equals 0. And I'll leave the other three to you. All right, so next I got end behavior. End behavior is still on the board. End behavior for rational functions. Compare the degrees of the numerator and the denominator. The degree of the numerator is less than the degree of the denominator. So right here, in A, the degree of the numerator is less than the degree of the denominator. Because in this case, the degree of the denominator is 1. Degree of the top, I guess, is 0 or whatever. So the bottom, the degree of the bottom is greater than the degree of the top. So when that's the case, when x approaches positive and negative infinity, f of x approaches 0. Wah. So anyway, that's my end behavior. So I'm abbreviating because you're supposed to write both. You're supposed to write as x approaches positive infinity, f of x approaches 0, and when x approaches negative infinity, f of x approaches 0. Yes, ma'am. Hold up. Yes, ma'am. It's not going to be all these. I was given a bunch of examples, so I'd have some for me to do and then some for you to do. But since Akira starts speaking out of turn, we probably gonna just add some problems on there. Or what? So anyway, so in behavior. For instance, let's look at D. In behavior. If I got a problem like that, what's up? Okay. So in behavior, what would end up happening is I would lose or I would reduce an x on the top. I would look at the most significant term, and so it'd be negative 7x over x to the third power. So I would cancel off of x, and I'd have negative 7 over x squared. And this is another problem where the degree of the bottom is higher than the degree of the top, so I would just follow those instructions. That as x approaches positive infinity, f of x approaches 0, and as x approaches negative infinity, f of x approaches 0. So let's look at B. What's the degree of the top? What's the degree of the bottom? X, right? So the degrees are the same. If you look up there and it says when the degrees are equal, what you do is you go for the ratio of the coefficients of your two variables. So in this case, it's not really that difficult because that's 1x over 1x. If I cancel off the x's, if I don't think about that, it's just 1 over 1 or 1. So then as x approaches positive infinity, f of x approaches 1. As no, because these aren't the coefficients. Remember what happens is x is changing. X is changing. The constant is not. The constant becomes inconsequential. Then yes, it would matter. Yes. See, here you don't have to be sorry. The thing is like this. If I said x equals 1, that 9 and that 4 kind of make a difference if I said x equals 1. When I said x equals 50, the 9 makes maybe a little bit of difference, but not really. When I say x equals 1,000, the 9 and the 4, they become kind of inconsequential. I mean, 1,000 is going to be 1,009 over 996. So it's like it's almost like it's 1,000 over 1,000 because those numbers become less and less significant as we put bigger numbers in, right? But if I had, like Akira said, if I had 9x squared plus 5 and negative 4x squared plus 8, and so this is inconsequential. These two things will cancel each other off, and this is what my end behavior would approach. Does everybody follow? Yeah. You focus on the one that has the highest degree. Say it again. Because there's no variable. The degree is the highest exponent of your variable. If there's no variable, then there's nothing there. So honestly, I don't remember off the top of my head if we just say it doesn't have a degree or we say the degree is zero. But whatever the case, x is definitely higher. All right, and then obviously we got problems like e and whoa, is that man? Dang it! I made too many of the same type. I needed to have this be x squared over x. So e is the only one that we got where the numerator is more than the denominator. And if the numerator is more than the denominator, you just follow the pattern. If I've got x, excuse me, as x approaches positive infinity, in this case, um, I would forget about the numbers and look at these, and 1x cancels off from each, and I'll have x squared. So if I got x squared, as x approaches positive infinity, f of x approaches negative infinity. I'm sorry, not negative infinity. Dang it. Sorry. I'm so sorry. Try that again. As x approaches positive infinity, f of x approaches positive infinity. Because we're talking about x to the second power. It doesn't matter if you put in a positive or a negative number, you're going to get a positive number. So x approaches negative infinity, f of x still approaches positive infinity. So that's what happens. I would consider what's left. Question on question? Mm, okay. So then we got two functions. You need to state the domain of each function. Well, the domain, we already know how to do that. In behavior, we just talked about how to do that. And then we also just recently talked about the vertical and horizontal asymptote lines for functions. I believe the vertical is based off of your denominator. So my vertical asymptote lines, I would see what are my excluded values in the denominator. Those are my asymptote lines. You understand what I'm saying, or am I talking to myself? All right. So let's look at this. If I look at the denominator, what does that factor to? Okay. Oops. So I got x plus 4 and x minus 4. So then I look at the top, it doesn't do anything. So I have two values that are excluded. And because I have two values that are excluded, that means I'd have two vertical asymptotes. I'd have x equals 4 and x equals negative 4. Now, I want you to think of the graph, the way the lines work. So this is the x-axis, this is the y-axis. Okay, so if I was telling you, I said the vertical, the vertical asymptote lines, that's x equals 4 and x equals negative 4, right? And then, yeah, that's pretty much it. The only other thing is, let me make a slight change so I can make sure you understand this. This is kind of where some confusion came into play. Let's just say, for instance, that the top of this was x minus 4. So when I'm looking at asymptote lines and the top and the bottom, they cancel off, I don't count this one as my asymptote line. Does everybody understand what I'm saying? That's something weird about getting your asymptote lines because we just did domain and it said it don't matter if you do this, you still got to count that stuff. But for your asymptote lines, when you're looking at that, you don't have to count this when you cancel it off. Does everybody understand what I'm talking about, or am I talking to myself? Okay. Yes. All right. So that's all of these. I'm sorry. I hate to interrupt, but I forgot to do the horizontal, so my fault. Horizontal follows the end behavior. So I look at the horizontal, and if the numerator is less than the denominator, then my horizontal asymptote would be y equals 0. If my if my degrees are the same, right? If my degrees are the same, just like the end behavior was the coefficients of my variables, the horizontal asymptote is the same as the coefficient of my variables. So if I look right here, they're not the same, so that doesn't matter, right? So I go to this and let's see, I have the top is less than the bottom. So then that would be y equals 0 for the horizontal asymptote. When you do this, I want to make sure you label which one is horizontal and which one is vertical. Yes. If there's two problems there, yes. All right, so vertical asymptote and horizontal asymptote. Okay, so anyway, back to what I was saying about the Blasi and behavior. Like I said, we talked about how to do that. In behavior, this is x approaches positive infinity of x approaches positive infinity. I don't even know. I said this was on the bottom was more, so I'm sorry, that's approaching 0. Man, I blame Kamaria. So as x approaches positive infinity, f of x approaches 0, and as x approaches negative infinity, f of x approaches 0. Yeah, because that's the same. Yes, that's fine. And then the domain is all real numbers except, so all real numbers except for 4 and negative 4. So that's how I would do that. So anybody got any questions on that? What's up? All right, this is something that we've been doing. Composition of functions. So I need to take the g function, that's my inner function, and then I place the f of x in there. So what that's going to be is 3x plus 2 to the second power. Does everybody see what I'm talking about? Wait a minute, that's not it. You know what? I'll you piece of candy. Yeah, it would be 3x squared plus 2. Yep. So I'll you piece of candy, man. I'm sorry. Yep, you were right. Yep. But now if I look at g of f of x, right? So yeah, this right here. Yeah, you can't factor it. 3x squared plus 2, there's nothing you can do. Now, if I'm doing this one, that's the one that is 3x plus 2 to the second power. Because first I put in this, and then I put this into that. And so you get that. But I'm going to tell you right now, I don't want you to give me this as the answer. I want you to FOIL it out. So that would be, let's see, 9x squared. Let's see, that's 5x plus 5x. So that's 10x. And then the last is 9. So that's what I want, not this. All right. So what about GG of -3? So all I do is nest or put the inner function as G and then I put the outer function as G. So that's going to be x squared and then another x squared or x to the fourth power. Yeah, I definitely rather you put it as x to the fourth. Yep. But hold on though. There's an actual value, so I gotta take that x to the fourth and put -3 in there, and then do x to the fourth. So -3 to the fourth power, that's a positive 81, and that would be my answer for C. Anybody got any questions? All right, I'm going to finish these last couple, and then I'm gonna stop the recording. So next, I got f of g of -1. So g of x is x squared, so that's going to be g of -1. G of -1 is -1 to the second power is +1. So now I've got f of +1. So I'm just going to have 3 plus 2 or 5. So that's how that's going to work. First, I plug the -1 into x squared. Then I take the answer of that and plug it into f. All right, so then the last two. I've got f of 2 and then g of 2 as my outer function. So f of 2. I plug in 2 for x. So that's going to be 3 times 2, that's 6. 6 plus 2 is 8. So I'm going to have g of 8. G is x squared, so that's 8 squared, that's 64. And then finally, I'm going to have f of x. So I'm going to have 3x plus 2 on the inside, and then I'm going to have f of x on the outside. So wherever there's an x in this function right here, I'm going to plug in 3x plus 2. So that's going to equal 3 times 3x plus 2. And then the last one is, like I said, if I got f of 3x plus 2, and then I need to plug that in again, so I'm going to have 3 with that in there plus 2. So then I need to distribute. So that's going to be 9x plus 6 plus 2, which is 9x plus 8. And that's the end of it. And so now I'm ending this.